All right, so I'll just say welcome and thank you for joining us today. There's been a huge number of responses, emails, and reflected by the number of attendees we have online from Australia, New Zealand, and even a few further abroad. It really stands as testament to the fact that educators around our globe are keen to prepare themselves and develop their training centres for EVs and alternative fuel technologies. During the webinar, the Q&A function will be active, and we welcome your questions or shout-outs, as we're seeing at the moment. And you can find the Q&A button towards the bottom of your screen if you haven't used that before. Please send questions through at any time. One of the team will monitor these, and we'll try and respond to your queries either at appropriate stages in the webinar, or we'll also have a Q&A session at the end. We're very happy to remain online, so we thank you for your time. It's pretty interesting. I'll introduce Daniel and I in a moment. But over the last decade or longer that he and I have been discussing hybrid and electric vehicles, I'm not really sure there's a technology that sparked more debate. You know, passions for petrol engines, the at times on-off progress of battery technology, the look and capabilities of earlier models and so on. You know, I was often met with that, like, don't get me started, and we understand that. But since the time we deployed our first hybrid and electric training systems about 10 years ago in New South Wales, a lot has changed. An article on this month's Targa West talked of the Tokeva team's Tesla finishing first in the Targa 165 and 10th overall, and apparently the extension cord jokes of yesteryear had pretty much all but died out, almost. Over the period, there has been a clear focus on reducing emissions and our reliance on fossil fuels, and in recent years, we've seen international governments setting dates banning the sale of new petrol and diesel engine vehicles. Dates in 2040 have been brought back to 2035. The UK is now at 2030, in line with Germany, where Daniel is, and Norway sits at 2025, with some reports indicating the EU is considering adopting this across the board. The OEMs are naturally adjusting their lineup. A lack of infrastructure and incentives are often cited as reasons for the relatively slow domestic EV uptake here. And while I agree that Australia and New Zealand have their own markets and will need to determine appropriate local strategies, I don't think there's any doubt that it's today's apprentices and technicians that you on this webinar are training, not those that are joining the profession 5 to 10 years from now. They're the ones that will be relied upon to service and maintain these vehicles. So thank you for showing an interest. Thank you for attending this webinar. We hope you enjoy. To give you just a quick background before I pass over to Daniel, he and I first crossed paths when he was an automotive teacher at TSA in Murray Bridge, and I had just started at Training Systems Australia. And don't take any offence, that shortly after that meeting, Daniel hopped on a plane and left Australia bound for Germany. With his passion, though, for improving vocational education, it made a lot of sense for him to meet up with the team at Lucas Nuller, leaders in the development of vocational training systems for now close on 50 years. Training Systems Australia and Lucas Nuller have enjoyed a long partnership, and together with our clients, we've conceptualised, equipped and support many of the most advanced technical training centres in the region. Across fields such as electrical, industrial automation, power engineering, and many more, as well as automotive, I'm fortunate to have gone on to head the team here and to work with many of the leading public and private training organisations in both Australia and New Zealand. Daniel did join LN's Automotive Training Systems team. One of his first systems, the Unitrain Fundamentals of Automotive Electrics, continues to be a huge success. A number of people on this call use it, and really thousands of units form a key part of automotive technician knowledge and skill development around the world. But it was really during a project in 2012 that Daniel identified a gap and significant need for hybrid and electric training systems. Since then, Daniel's gone on to head the LN Academy and work with the IMI, the Institute of the Motor Industry in the UK, the ASE National Institute for Automotive Skills Service Excellence in the US, the DGUV in Germany, and many of the industry's major manufacturers. And from 2018, Daniel has acted as advisor and supporter to Skills USA and World Skills International in relation to EVs. Daniel, a super impressive CV. Thank you for joining us this evening.
Thanks, Dave.
I just thought maybe to give everyone a bit of context. Obviously, there are people on the call that have met you, have met me, but plenty that haven't. To perhaps you could share with us a little bit about how you found that transition across from teaching to life at Lucas Nula.
Yeah, thanks, David. First of all, just want to say good day to a few familiar faces out there, or familiar names. So good to at least see your names there. Looking forward to catching up again next time we're in Australia, whenever that will happen. Yeah, it's been an interesting transition. So as you mentioned, was working at TSA in Murray Bridge, South Australia, and I find basically from now that I have an outsider's perspective, I've been living here in Germany for around 10 years. My role here at Lucas Nula, I mean, we set up projects, automotive training projects all around the world. And my role has been to go there and help set up those projects, train the trainers, kind of show how to use our equipment in classroom situations, things like that. And, you know, I left Australia where there's the apprenticeship system. I came to Germany where there's also the apprenticeship system, as they call it here, the dual system. Dual meaning, you know, on the job and training. And so I kind of naively assumed that was all around the world, and it's not certainly the case. Basically, Australia is the only non-German speaking country that has an apprenticeship system in the classical sense of it. There is it in bits and pieces, but kind of on that national level, there is no other country. So it's good to see how basically they took the best of all of the different systems from around the world. So here in Germany, for example, I mentioned it's the dual system, but it's not quite right. So you've got, obviously you get your job first. By the way, every apprentice starts on August the 1st or September the 1st as a second intake, and that's it. And then every apprentice is in lockstep throughout the country. So a little bit different to the way we do it in Australia, where, you know, we need to be kind of more flexible. And then also when it comes to the training, you've got the on the job, but then here in Germany, you have what's called, so Berufsschule literally it means trade school. And then you have Handwerkskammer, which is the Chamber of Crafts. And they kind of split the learning up so that the theory is done at the trade school, and then the practical is done at the Chamber of Crafts. I mean, that's a basic way. And so it's good to see that, you know, TAFE and the way we do training in Australia is able to make that even more efficient and blend those two together. Of course, that, in my view, makes the most sense, you know, blending theory and practical together. And so that's been really interesting to see and to kind of promote that in other countries as well. I think the other thing that I learned so much in Australia was, you know, the training that you do to become a TAFE teacher, a lecturer. You have to understand training packages and kind of understand, you know, what's assessment criteria, skill competencies, things like that. And so that's really helped us here as well to help other countries around the world. You know, they either got their own standards, and so one of my jobs here at the LN Academy has been to analyze what's going on with a, you know, a certain skills package, and then make sure that we cover that here with our equipment. So with either the skills, making sure that we have hardware that the students learn, or we have the theory that is covered in the e-learning as well.
All right, sounds interesting, and obviously we'll forgive you when you're looking for the right word with the German one at the top of mind.
Yeah, it's a bit of a worry.
Hazard. I know you've got a presentation which addresses that and looking at curriculums, and obviously here to talk EV this evening, and you're well credentialed to do so. So I know you've got some tips and tricks for the guys, and you'll also talk about the training systems behind you in the background. So what I'll do is I'll disappear from view so you can share your screen, and then I'll jump in with any questions that pop up along the way, or one of the team will, and then we can chat a little bit after we've done that presentation around lab planning and the like. Again, I encourage people to shoot through any questions they have along the way.
Perfect. Yep, thanks. Okay, yeah. So just want to have a little bit of a look at some of perhaps what the stand is in Australia and New Zealand as far as qualifications, but also to give a little bit of an idea of what's going on internationally. I know that's sometimes interesting. In Australia, New Zealand, we're often forgotten about down in the corner there. And obviously there's been no chance to do any travel for the last couple of years. So just thought might be interesting to give a little bit of a perspective of what's going on around the world. So just to reiterate, so in Australia, there is 3 skill sets that are there, and huge shout out to Neil Hurnishan, who put these together back in the day. They've been around for a while now, and they were some of the first standards in electric vehicle training, or in this case, hybrid and electric vehicle training. There's a split between the two, and you can just see some of the units of competencies that you see here. So huge focus on diagnosing, depower, reinitialize, so isolating the vehicle, and service and maintaining battery electric vehicles. And this is what I mean, there's a difference between EVs and hybrids. Not really, there's probably a product of how old the units are. They've been around, like I said, I think for about eight or 9 years. Hybrids were, a lot more predominant back in the day, probably less so nowadays. And again, you're seeing the similar sort of things, but with a focus on hybrid vehicles. And then also now looking at a purpose-built diagnose and repair skill set as well. So going into a lot more detail about the electric motors and essentially the auxiliary systems that you find on hybrids as well. Just to have a look at the New Zealand perspective as well. So there's a certificate for electric vehicle automotive engineering, and you can see here what's covered within that as well. So similar sort of things, drive system, batteries, and the auxiliary systems. And also in New Zealand, you've got some micro credentials as well. So there's working safely with electric vehicles. I believe that's from Maito. And you can see the units that are involved there, and also electric vehicle battery repairs. But unfortunately, I couldn't find much information on that one. But I think that the units involved, or the information involved, is obviously going to take a deeper look at electric vehicle batteries, or high voltage batteries in this case. So that's kind of what's going on within the region. Just a little bit of an idea of what's going on around the world. So we partner with, as David mentioned, IMI, Institute of the Motor Industry. They're a UK organisation, and we partner with them because they offer an international qualification. So we offer the equipment, as I mentioned before, the equipment and projects around the world, and we get a lot of our customers say, okay, we need to do their training, and where possible, we'd love to offer a qualification as well. And so, and if they don't have anything at that national level, which is actually very common, especially electric vehicle, I mean, there's plenty of countries that don't even have light vehicle qualifications, which is something else we're trying to work on. But even at the EV, where you're talking kind of a week to 2 weeks training, they don't have any national qualifications. So together with IMI, that's something that we can offer with them. The second kind of, it's a brochure that's from, as David mentioned, DGUV. That's kind of like your occupational workplace and safety organization here in Germany. It's it's essentially the insurance, workplace insurance. If you get hurt, then you will need to be, if you get hurt and you haven't been trained on this, you don't have this qualification, you won't be covered by the insurance there. And so that's quite interesting. So that's baked in at that legislation level as far as training and insurance is concerned. And so that's kind of what we're seeing. And the way the qualifications are outlined is more about job roles as opposed to what type of vehicle it is and the technology behind the vehicle. So Starting off at level 1. Level 1 doesn't necessarily mean the academic levels, but it kind of still fits. So level 1 would be non-technical staff, really just an awareness training. So dealership staff that might be driving these vehicles. They're not going to be working on them, but they need to be aware about what can they touch, what can't they touch, how to charge the vehicle, how to identify a high voltage vehicle, things like that. You've got level 2, which is then technician level, and that's basically it's being able to isolate the vehicle. So obviously there's a huge amount of safety here to understand what you can and can't do, but the very basic end result is being able to isolate a high voltage vehicle and then say remove an air conditioning compressor, high voltage air conditioning compressor, or the inverter, or do some testing on the motor. The highest level, so level 3/4 would be also technician, and this would be more your advanced technician. So this is working on the high voltage batteries, because of course the high voltage battery always contains high voltage, and it has the most potential for danger. Another standard that's out there is ASE, and I know some of the guys at ASE through my work at Skills USA, and I know that they're looking at doing some pilot projects in Australia, so that may or may not be relevant in the future, but they also have a, you can see it here, the specialist test, L3, so that's kind of the next level. They have the A series test as the introduction, and then you have this level here, which is the specialist. That's kind of a one-size-fits-all solution, but with a high emphasis on, say, isolating the vehicle, selecting the correct equipment, and being able to do installation testing. I think what's interesting here, there's a real opportunity in Australia, New Zealand, and certainly what I see from the European and the American perspective, and I think it's really a lost opportunity for kind of a next level of training for automotive guys. So, I think if there was a chance for, say, a master technician in Australia, I think that would be something that a lot of people would jump to. A lot of guys are always looking to kind of learn and upskill and things like that. And, that would be great to see within, my experience in Australia. More of that level 4, still technician, not going really into the management side as, it often can do, but kind of upskilling into more of that diagnostic technician, which is something, obviously here in Germany, you've got the Meister, and in the UK, they have the master technician status as well. I think that would be a pretty cool thing to have in Australia. So that's what's going on internationally. There's a few little countries here and there have their own qualifications, but these are kind of the standout ones. What's also interesting is that there's a first responder training. So also from IMI, and now here in Germany, they've identified the need to have firefighters, police, even through to tow truck operators, crash repair, and they're usually calling this like a hazard management. So it's different from that awareness. It's obviously more about awareness of what's going on, but it's a little bit different. So what to do when the vehicle has been damaged in some degree. So, and it brings up the question is, when is it safe, how to achieve this, but also how to keep other people safe as well. It's not just about keeping the firefighters, but securing the area so that no one else gets hurt, for example. So what can be touched, what has to be avoided, and as I said, non-technical awareness training. So some of the challenges that we're facing here are really the safety knowledge requirements. So, what do you need to do to keep safe? What are the dangers and how can you avoid them? And then obviously there's some technical knowledge and competencies as well. And this is just a little interesting statistic here. So basically, right at the moment, the IMI, they're kind of like the Skills Council within the UK as well. So they set the standards for automotive training in the UK. They're saying that there's only 6.5% of UK techs are ready, trained up for high voltage vehicles. And that's not even to that highest level. This is just at the that first level, how to isolate a vehicle. So there's even less that are ready to work on the high voltage batteries. And so, you know, we're doing a huge amount of work in the UK at the moment because, as David mentioned, they're already looking at 2030. If you have a look at the news at the moment, it looks like they're banning petrol cars already because they've run out of petrol. So they're just, you know, going crazy trying to train everyone up at the moment. So if we just have a look at some of the safety concepts there, so it really comes down to understanding the dangers, live high voltage, the correct PPE, personal protective equipment, and the appropriate tools. And also to follow isolation procedures, follow and understand isolation procedures. And I think this is the most important step, verify voltage-free state. So not just shutting it down, but also making sure that it is shut down. I did some Prius training when I was working with Toyota, 2004, and we just got told, yeah, just pull the service plug out, and you know there wasn't even a huge focus on gloves or anything like that. Pull the service plug out and wait kind of 20 minutes, 30 minutes, and then you should be right to work on it. There was none of this checking it and things like that. So it's interesting that, you know, it's slowly becoming clearer and clearer as to what we need to do there.
Daniel, just on that, we've had a couple of questions coming in, and probably one that's relevant because this is probably second nature for electricians, but is somewhat new in the automotive space. And there's a question that came in from Robert saying, you know, would it not be an electrical fitter's role to repair electric cars, trucks, as you know we're seeing in some of the mining industries at the moment? Are you seeing that overseas? Is it the domain solely of electricians, or what's happening, or electrical fitters rather?
Yeah, no, it's an interesting question. So I think basically, so here in Germany, they've combined the two. So it's basically there's no just a light vehicle mechanic anymore. It you know, here, for example, they call it a mechatronic. So mechatronic technician, you know, is combining mechanical and electronics together. As far as electrical fitters, like if you're talking about electricians, yeah, in the mining sector, that's probably a little bit different, but there's also, essentially it's coming down, you know, we're seeing the merging of automotive electrical guys and mechanical guys into one. That's kind of what we're seeing around the world.
Yeah, it'll be interesting because we're also, it was flagged by Ron and Marcelo also that the new there's in the pipeline the standalone AUR 32721 Cert 3 in EV Tech, which is kind of in the pipeline, which is, you know, to be released, which has got some new units in it around you know, diagnose, repair complex faults and the like in EV powertrains. So it'll be interesting to see when that comes through, how that actually also translates into the actual training and who's going into that space as well.
Yeah, definitely. So see the work that I think PricewaterhouseCoopers are doing that now. Yeah, that's interesting. So thanks, Ron and Marcelo. Also notice there's a question there about what do we call high voltage. That's a pretty fundamental question too. You know, it's kind of, we can forget that you know, it's a fundamental question. So high voltage in automotive terms is 60 volts DC, 30 volts AC. So, you know, we've got here at Lucas Nula, we've got electrical engineers, all that sort of thing, and they laugh at us when we tell them high voltage is 60 volts, because they're talking in thousands of volts and things like that. But obviously, with a DC battery pack, you know, 50 kilowatt battery pack, it's still, the danger is there to get killed. So essentially, anything above 60 volts is considered high voltage. So just got some of the different safety equipment there. What's interesting about the insulated tools there, you can kind of see the two layers within there. So you've got the orange layer on the outside as a warning, and you can kind of see that yellow layer on the middle there as well. And that's actually there for safety reasons, so that if you accidentally, you drop the tools or chip that insulation off, you will see quite clearly the yellow underneath. So that's there on purpose so that you can kind of determine if the tools are no longer safe. Also just got a little video here that I want to play very quickly. So that's a real connector. Obviously it's set up for a test there, but it had 300 volts with just 10 amps running through it. So 10 amps is basically nothing as far as electric vehicles are concerned, but you can see the arc flash that was created there. And that's that visualizes what the dangers, the potential dangers are of these vehicles. So you can see here also we've got a face shield. You know, obviously wearing glasses is a very smart thing to do, but in cases like this, and certainly working on the high voltage battery, having a face shield is absolutely critical with the whole wraparound neck thing. Because what happens is when something like this happens right in front of you. Now in this case, obviously the interlocks were removed and things like that, so it was a little bit staged, of course, but just to show. But the potential is always there. And when that happens in front of someone, the human reaction is, of course, to kind of suck in, and you can breathe in those flames, the fumes, all that sort of thing, and you kind of burn yourself from the inside. And so that's why you need to have things like the face shield there. And in the end, what it really comes down to as educators, we've got to create a culture of safety. So here's just a couple of random examples. This guy on the left is working on a Nissan battery. He's got gloves on, but they're not insulated gloves, and he's poking around with the high voltage section there. So that's getting pretty dangerous. The guy on the right here, this is a case of everything. If you can do something wrong, he's done it. So there's no face shield, no glasses, no gloves. He's got a pair of pliers there, which are not insulated, and it looks like he's using them as a hammer almost to knock something out there. And so it's a nightmare. You've got, so I think in this Prius pack there's around 28 cells or something like that. Well, not even cells, there's 6 cells in each of those modules, and the voltage is up around 200 volts. We actually had a customer of ours in Malaysia. They bought these systems, and they had a full vehicle that they got from Korea, and it had little wires going to each of these cells so that you can measure the voltage of the battery. The teachers thought, okay, this is great, we can see what's going on here. There was no protection whatsoever on that. There was, it was a cable straight from the connector to the battery cells. And when we started exploring it, if you measure across 2 connectors, you can measure 7 volts or something like that. If you measure across the whole thing, you're measuring 200 volts. As soon as the teachers realized that, they absolutely crapped themselves. They were, oh my God, all of a sudden that vehicle got put over to the side until they could basically remove all of the breakout box and things like that. So I think as the role of educators, and then as David mentioned, there's going to be young ones they're going to be, the people that are being taught right now are going to be facing these vehicles at some point in the future, whether we like it or not. And so this is a really interesting thing, and I think it's up to educators to really develop that culture of safety. So for example here, using the correct gloves and the correct tools, and also not just about keeping yourself safe, but others as well. So you can see here, putting out the barriers around their signs to let everyone else know that, look, this vehicle is a high voltage, please keep out, please keep safe. And so one of the things that we've been doing over the years has been partnering with World Skills around the world. So you can see here, Kazan 2019, that was the international event in Russia. Skills USA for the last few years, France, Germany, many other countries. And it's a way to introduce the topic at their national level to make educators aware that, this is coming, let's do something about it. And so I just want to give a little bit of feedback on how that went. So if you have a look here, Skills USA, this was the first time that there has been a high voltage skill station. So there's been high voltage vehicles at skill stations around the world, but they don't work on the high voltage part of the system. So Skills USA have for a number of years wanted to have hybrid vehicles, but they were too scared to actually have a vehicle there. So having untrained students working on it that haven't prepared, don't know what they're doing, getting the vehicles to do that, and then potentially damaging the vehicles as well, and then obviously then potentially injuring someone, either a judge or a student. So the idea here was an introduction to the topic of hybrid and electric vehicles, just to, like we said, to broach the subject and get people thinking about it. So, and this was the national level where the students come from the regional, they win their regional events, to the state, and then to the national, and then go on to World Skills from there as well, World Skills International. And so at this point it was perform a vehicle shutdown, isolate the vehicle, verify, put it back together again. And then, we've got plans to extend that over the coming years. We'll start putting in faults with insulation faults, and then, which we started to do as well, right through to battery cell swapping and things like that. And you can see here, we didn't just give the students one pair of gloves, we gave them many pair of gloves. So I'll do a practical session very soon, show what that is all about. But the results were very interesting. So less than 50% of the students had any high voltage experience whatsoever. So that doesn't mean working on hybrid vehicles, that means even being taught anything whatsoever at school. And like I said, these are the best of the best students. They have very poor knowledge of the PPE, they had no idea what gloves, even though we had it all written in a short manual, told them what gloves, how to test them, things like that. They felt under pressure, rushed, and ended up picking the wrong things, doing the wrong things. We had students removing service plugs without any gloves whatsoever, things like that. And that's what we call here, many participants triggered critical events. So the potential for electrocution. So very interesting. So if we have a look at the technical side of this type of training, there's obviously, this is completely new technology for technicians. High voltage batteries, inverters, three-phase motors, DC to DC converters, insulation testing, potential equalization. And then of course we've seen in all of those units at the start there, they all talk about diagnose and repair. You need to have a high level of knowledge in order to diagnose properly and then to repair as well. So it's always great to see one sentence about diagnose. The ASE ones are great for that. It's one sentence says diagnose and repair inverter faults. Okay, that's one sentence, but you need chapters and chapters of theory and practical experience to actually do that. So one of the things that we do here is using the car train system is to try and get some hands-on experience as well and understand what the measurements are. The difference is if you're using a real vehicle, and we're not trying to replace the real vehicle in the training, but we're trying to supplement it. So a real vehicle is not really intended for training. In this case in particular, you've got so many levels of safety built in. There's electrical levels with interlocks and things like that. And then you've also got mechanical, so you've got covers. The batteries are either on the bottom of the car, under the boot with the carpets and seats and things like that. So they do that deliberately so that it's safe for everyone. And that makes it a little bit hard to teach with as well. And then if you go to the point of actually taking measurements of three-phase motors and things like that, it's all really cool to do that. But we're talking about teaching young people here who don't have the experience and the skills. And so, it really becomes a question of safety. So just a quick look at some of the signals that are a bit different. What does a digital three-phase motor signal look like? How do we drive a three-phase motor? Active discharging, passive discharging, resolvers, the charging, communication, things like that. some of the test procedures that you do, insulation testing, isolation procedures, live dead live testing, and so many other things, potential equalization. You know, it's all stuff that you need to do practically. Just a bit of a, you know, background on the high voltage battery as well. So got a couple of specific examples here. Hybrid vehicles back in the day were mostly nickel metal hydride, different variants sometimes, things like that, but essentially, you know, very short range, but the battery is more of a buffer for regenerative braking, things like that. Anything that's plug-in, so even plug-in hybrids to battery electric vehicles, basically all using lithium batteries. So there's a couple of points to be aware of lithium batteries. So they're dangerous goods, so it's not quite so easy to send them around anymore. So back in the day with Toyota Prius, we were able just to order a new one, send the old one back as a, you know, with a deposit, and they would repair it, send you out. You'd have a refurbished battery. It's not so much the case anymore. I mean, here in Germany, basically the manufacturers have said, we're not going to do that. The dealerships have to be ready and able to fix these batteries themselves. So they're doing cell swaps at the battery level. So going back to those qualifications that I went at the start, every dealership has to have someone at that level 4 kind of level to make sure they can fix the battery. So understand what's wrong and then also be able to repair it. And so, you know, from a training perspective, you look at these batteries, you know, it's, again, not like the old Prius where it's bolted on there. There's lots of bolts, but you can unbolt it and take it off. These are usually watertight, these batteries now. So they're glued all the way around with something like the windscreen sealer type stuff. And very often you have to cut that, which often destroys that lid of the battery. Not always, but pretty often it does. So, and obviously very high energy. So up to, you know, Tesla with their 100 kilowatt batteries, that's a huge amount of energy in these batteries. And so, you know, we've got a lot of these, basically all of the German manufacturers have our battery trainer, which I'll show you shortly, because they say, look, as part of that qualification, you need to have an understanding of high voltage batteries, but also have to have experience with faults that you find in the batteries, you know, with the contactors, with high resistance within the cells, just certain things like that, battery balancing. And so the trainers are saying, are you crazy? I'm not going to do that. Like someone at Audi, they have to get their vehicles from new car sales. You know, that's a usual deal. They get a new vehicle, remove the battery, cut the lid off, and then introduce faults into the high voltage battery. And we're not going to do that. You know, we need to see them, but to put faults in a real vehicle, in a real high voltage battery, is just too dangerous. So they have to cover those topics, and so they're using systems like this to do that. And of course, again, high voltage batteries are always high voltage, even if you shut them down. So we all know the service plug. Service plug is the, you know, the hard, basically a switch which you remove from the system. But all that's doing is kind of separating the battery into two pieces. It still has high voltage, just a little bit smaller than it was before. So that's that high voltage battery trainer that I was talking about before. This is the one that we're using for kind of the next level, diagnostic technicians, and just to make it a little bit more accessible and understandable as well. So just makes it a little bit easier to understand what's going on inside the battery when you can really see it, which is really the philosophy that we have. So that's the end of the presentation there. So what I'll have a bit of a look at. Yep.
Just while, you know, we're on that topic, and you've obviously covered the safety elements, a couple of questions that have come through in relation to it. You know, thinking about, again, Robert mentioned that, you know, in WA, you're going to need to have a restricted electrical license to work on those voltages. And Tim was also saying, do you think there's going to be a time where registration is effectively going to come in for technicians who are qualified on vehicles. So if people aren't qualified to a particular level, that they can't legally work on them. And, I know you talked about the DGUV and the workers' comp insurance requirements. Is that something that's pretty much happening everywhere?
Absolutely. So like I said, the DGUV in Germany, that is, it's like occupational health and safety. There's no if, buts or maybes, no grey zone. It's, you must do this to be covered. And so they're, in the UK, they're pushing really hard for licensing, most likely, to work on these vehicles. So it probably, I don't know, I'd like to see this new, I couldn't find the information. I guess only people that were involved with the development of the new AUR qualification there. I'd like to see that. I'm not hearing any talk in Australia at the moment, but yeah, it's certainly interesting about the
it's something you're seeing
Australia there.
Yep, sure.
So, yeah, any other questions there, or?
I think you'll probably come to it in terms of, there was a question about, when you determine depowering is required. Again, you'll talk, I suspect, a little bit about when and how when you do a demonstration of the systems there.
Sorry.
And also, sorry. Yeah. No, that's fine. And
talking too much.
We're seeing that developing HVIL and insulation type tests and faults, which I think also comes into play on some of the stuff you've got there behind you.
Yep. So what I'll do very shortly is have a look at insulation fault, HVIL, for those not familiar with the term, high voltage interlock. And so that's the electrical interlock that triggers basically when you open any of these systems. As far as determining depowering, so that really depends on what the job is that you need to do. Mm-hmm. And again, that kind of comes down into the different standards. I've heard people, they want to isolate the vehicle to switch the tires or do a service, things like that. I think that's probably a bit overboard, but we kind of need to see what. Basically, we always say follow the regulations and follow the manufacturer specifications. But certainly working on any of the HV system, then definitely need to depower the vehicle.
All right, I'll let you continue on, and we'll come back to some more questions in a moment.
Okay, no worries. So what I'll do is I'll just switch over here. Sorry, just catching up. It's pretty early in the morning here, just having a drink of coffee.
We appreciate you getting up early.
So this is the car train system that I've been talking about. Got many other different systems, but just want to focus on these today and how they can perhaps help in electric vehicle training. The panel that you see here is essentially has all of the equipment that an electric vehicle has, just in an accessible way for the students to kind of experience the system, understand what's going on with hybrid vehicles, and get that kind of hands-on experience of what they might see, which is sometimes a little bit hard to find on a real vehicle. You can see here we've got like a breakout box with some block diagrams on there. The idea of that is with this system here we can essentially simulate different types of hybrid vehicles. There's a whole bunch of hybrid vehicles, hybrid drivetrains on the side of the system here. We all know there's now, I think there's something like 50 different hybrid concepts, but essentially if you break it down into the fundamental, there's basically just 5 different types of vehicles, and we call them high voltage vehicles. Some people call them electrically propelled, things like that, but essentially it's just series hybrid, which is kind of like an electric vehicle with a range extender. a parallel hybrid, which is, everyone's familiar with the old Honda systems, the IMA, that was like a booster for the combustion engine. Series parallel, which is your classic Toyota, where you're combining both of those with a planetary gear set in the middle. Electric vehicle, and even a fuel cell vehicle. So a fuel cell vehicle is also considered a high voltage vehicle because the fuel cell is essentially just a range extender. Still has a battery, and it has a electric motor as well. And so what we do here is we can essentially just switch out these overlay masks, and that just gives the students different option as to what they see here. Everything that's similar would stay there, obviously, with the if you've got MG1, MG2, motor generator 1, motor generator 2, etc. But it just gives them an easy way. And essentially what that means here in this case, I need to start it first. So just going through the startup phase to get the system into ready. And once we're doing that, here, for example, we can just visualize what the various drive modes are doing. So what's MG1 doing under load, under light acceleration? Where's the combustion engine? When is that being active? When is regenerative braking or regeneration occurring? Things like that. And so once I switch the overlay mask out, so I'll just do that very quickly, just to show that the visualization here also changes as well. So just, that can often be difficult. Even if you've got the vehicles in the workshop, you're not going to let the students drive them around on the streets to see that, even if they've got the cockpit that tells you what's going on and things like that. So just something like that is also helpful to understand. Together with this, I'll just share my screen to show what's going on there. This is a part of so this is the e-learning that David was talking about before, and David and his team really do a fantastic job, I have to say. They're our standout representatives all around the world. They look after the customer like crazy. We've seen, you can see here, we've done a generic e-learning course, which we look at all of the curriculums from around the world and make sure that we cover everything in there. So before it was the case, we had the German system, so we just put that on there, but we don't sell this internationally when we do that. So, and David and his team really make sure that they put that in, maybe break it down into the skill sets, things like that, just to make it so much easier for educators. So anyway, that's there, and you can see this is all the information that you find in there. Now, I'm not going to go through all of this because there's probably close to 30 to 40 hours of putting a student in front of this, going through all of the experiments. It's a huge amount, and we can offer to do some technical trainings if you want to go into detail. We have some videos online which go into it like 30 minutes just going through what's in the curriculum. So if you're more interested, or get in touch with David. His team has all of these as well, all of the e-learning courses, so he can also show you in much greater detail. So, but we just start off here with even the introduction. So, types of vehicles that you find, doing experiments on the system so that you can see you've just learned about hybrids. Now go through, perform the experiments here to understand what they are as well. So kind of starting, and this system here would be like your introductory system. So even, we got students, we even have, so in the US, even high schools buy this system. So what they call the community college is kind of like a TAFE over there. Loads of them have got it, manufacturers, but yeah, found it pretty interesting. Even high schools are using this. So the high school automotive programs are using this for just to train people up. Identification, the blue badges and all that sort of thing. So just starting at the background knowledge. Obviously safety is a huge part of that as well. Risk assessments, the PPE, going through the PPE, and things like the safety lockout box. We always try and put little animations everywhere to make it a little bit easier to understand. than just a boring old textbook with questions that are related to it all throughout as well. So don't want to go into too much detail about this, otherwise the webinar will go for a couple of days. Don't want to keep you all that long. One of the questions that came up was about Interlock. So that's also one of the units of competency within the skill set, the Australian skill set. So we've got a chapter on interlocks here as an example. So essentially with the interlocks are coupled together with either the system main relays or the contactors, depending on how you call them, which manufacturer. And this is a cool little animation that we put together, which I find really interesting. So you can, and this is actually based on the other trainer that we got here, but it's also exactly the way that most manufacturers do it. Some use a pulse width modulated signal, but most use this signal here. So this is a constant current with 12 volts coming through the system. And you can kind of see here you've got a number of resistors, a resistor before and after. And then you've got some bridge connectors, which are a part of the connectors. So either the connector or on the lid of the inverter, all of these have some sort of bridge connector, which when you remove it, can see here bypasses obviously the bridge connector in that case and goes straight through a resistor. And because we have constant current, it changes the voltage that you see in the middle here. And that's how you can determine what the position that is being open. So something simple like that, I often wondered how you could do that, and it's because there's different value resistors for each of those different connectors. So something simple like that, you can have any combination and the BMS will know exactly which of those connectors is open. So,
and you're just on that, you've got effectively some flexibility then, I guess, to look at different manufacturers, different structures, different drivetrains, and obvious that kind of more generic and broader approach to it all. Yeah, go ahead.
And I'd say that's really the German philosophy about understanding, the principles in general, and not kind of being specific about one certain manufacturer, but understanding how a system works and then being able to extrapolate that into, the real world.
Are the manufacturers fairly reluctant to give out information, or how are you seeing that as a...
It's really interesting here in Germany. Everyone cooperates really well. So, we work with Volkswagen Training Institute, Bildungsinstitute it's called. We work together with them. Everyone tries to look for that win-win. They think, okay, we can use these systems, and here's the information that will help you build a better training equipment or training system. So it's really refreshing to see that. Actually, it's really cool.
Great, thank you.
So, that's just one small example. And like I said, get in touch with David if you want to, if you're interested in going into a deep dive. I won't go into a deep dive today, but just give you a bit of a general overview. One thing I do want to have a look at though is electric motor. So that was one of the questions that came up.
So I'll just interrupt and say if anyone wants to actually make the screen with Daniel bigger, there's a line in the middle that allows you to drag the screens to the side, sorry. So they might be a little bit small and you might be seeing the content a bit big. So sorry to interrupt, let you keep going.
No worries, I was trying to, not sure if everyone wanted to see me up close anyway. Electric motors, so just I want to come back to this one here just to show the benefits of having e-learning and then blended learning as well. So being able to have a look here at how does a three-phase motor work. We're automotive guys, we're familiar with brushed motors, things like that, starter motors, alternators, but this is a bit different. Induction is coming through. So here we've got, an AC signal coming through, and as it goes through a coil, obviously you get repulsion and attraction that's coming through. Okay, that makes sense. With two phases together, you can begin to see how those magnetic fields interact with each other. Putting that together with three phases, now all of a sudden we've got a phase shift physically. So the coils are in different positions, of course, but we also have a phase shift with the input phases. So the three phases that are coming in are 120 degrees shifted from each other. And the result of that happening is a rotating magnetic field. So that magnetic field is rotating around in the stator, which essentially pulls the rotor around. So, you know, I've read technical textbooks which try to explain it, and it goes for pages and pages talking about formulas and trying to understand that, and here you can do it on one page just with some nicely built animations. And just to show what that looks like, just again, a nice little animation to show what that looks like in the real world as well. Those three phases fitted together and then plopped into that little, essentially the windings of the rotor there. So then we can go through and we can do a, oh, not that one, this one down here. So have a look at a measurement this time on the three-phase motor. So in this case here, the experiment shows you how to, the animation shows you how to build the experiment. So put the cables into the two phases of the motor. Now I come down to here. So you just see I pulled the oscilloscope up. We actually have a USB connection to the unit down here. And so that's going to the computer that I'm driving this, and I can now actually take measurements of the unit according to how the experiment is built. So I want to get the system running again. I need to get my time divisions done correctly. Time and voltage. And all of a sudden we can see there a three-phase signal, albeit looks a bit different to the signal that we had on the animation there, which we can go into about how inverters work and things like that. Perhaps I'll leave that for today if you're interested in a deeper dive as to why that signal looks like that and not the sine wave that we've seen before. Otherwise we'll just run out of time. In fact, I think we'll do a poll a bit later, David, to see if anyone's interested, so we can put that on.
Sounds good.
So you can see there, we just copied those results, put that in there, let the student, obviously I've done this one before, but the students then go through, ask some questions, and have a look to see what, if they've actually learned. And so that's what we call blended learning, to really mix that theory together with the practical. So what I'll do now is go through and do an insulation fault and an insulation test, what that looks like. So I'll just stop my screen here. So on the system over here, I've just put in a insulation fault, and you can see on the screen here now we've got like a little yellow triangle on here. So yellow triangle or red triangle, difference is, so back in the day it used to be just one triangle, the high voltage or the check high voltage system triangle, and the systems would shut down. A lot nowadays they're a lot more nuanced, and they can tell, okay, is the insulation fault critical or not critical? So in this case the vehicle can continue to run. It'll tell you, look, get to the workshop and check it out, but it will let you run. If it's a much more serious fault, then the vehicle will shut down, and with a red fault. So what I'm going to do is perform a isolation procedure and do an insulation test quickly just to show what that looks like. So you noticed before at Skills USA, the students had essentially a whole heap of gloves like this. And the reason we do that is we want the students to make a decision. So we've taught them what type of gloves, how to test the gloves, and basically decide which ones are right. So we're looking for class 0, 1000 volts. And what I do, for example, is I give them a bunch of gloves that are class 0, 1000 volts. And I also give them class 00, 500 volts. And so, and that was one of the things that we mentioned. We actually had students using the wrong gloves, the complete wrong class. Not only that, we gave them so the rest were okay, they were all class 0 gloves, but they didn't have a test date on them, or the test date is many years old. And then I also got a little bit tricky, and I put some holes in some as well, so that when they tested them, so you can either use, these devices, sounds like that rubber chicken that you can squeeze, but either use that. What I found, if you're doing this type of training, I highly recommend having just loads and loads of gloves. For this reason, make the students think about it, but also to do some experiments, because the rubber is so tight that you've really got to put a lot of force in it for them to leak. If it's a pinprick, you might not even notice it. So I had to put little, basically cuts with a pair of pliers to make it substantial enough to measure it. Try not to get the students to blow into it like that. It gets a bit manky after a while. So always try and do, you've got obviously proper test equipment, but at least getting the students to do it out in the field. We also had students that didn't put enough pressure into it. Like, you've really got to put a lot of pressure into these to test them correctly. So let's say gone through, we've tested all of the various gloves. I've got to a point where I'm happy. The other thing, we had students put the leather gloves on first and then put the rubber gloves on top. So I don't know what they're trying to protect doing that, but it was a little bit interesting as well. The other thing is the different types of test equipment. So even just to measure the voltage, verify the voltage. This is the one that everyone's aware of, most people use for hybrid electric vehicles, the old Fluke 1577. You can see here it has Cat 3 and Cat 4 rating. But what I do is I give them also one of these old guys. It's also a Fluke, everyone knows, great Fluke, cool, Fluke 88. But this doesn't have a Cat rating. It's 1,000 volts, but it's not Cat rated. And you can see also it's got the old school probes that you can poke through the wire. So obviously it doesn't just rely on the multimeter, but you've also got to give the leads. I also give them leads that have a little cut in them somewhere. So it's really about making sure they understand what they're talking about and making the right decisions. So we got to the point where we've got the right gloves, the right multimeter, things like that. So I'm going to do a shutdown now. So again, this is all covered within the e-learning. This is the super fast version. So first thing we want to do is remove the ignition key. And the point of having a real ignition key like that is to make them think about what they're doing. The point here is not to remove the key and put it in there, but we also want to go back. If you're in the workshop, you want your students to understand that they should try and get the vehicle started again. Go back and press the the start button, and see if it will go into ready mode, because often you get customers that keep their spare keys in the center console or in the glove box, things like that. So that we've certainly seen that before, where there's still a key somewhere and the vehicle can go into ready mode. So the other thing we want to do is remove down here, we've got the 12 volt battery. So remove the negative terminal there as well. And we want to remove the service plug. So on the service plug, and kind of best practice will tell you that all now goes into a safety lockout box. Not sure if you're all aware of the concept behind that, but safety lockout box with the special padlock. You would normally write your name on here, and you were the only person with this key. So I used to work in Olympic Dam in the mines, and we all had our own padlocks with our names on it. And if you put that on there, I think that's actually an offence to remove someone else's padlock. So, this is high level safety things here as well. That means the vehicle is now depowered, and it can't be started up again without, opening that box. The part we want to get to now is verify that the voltage has been dissipated. So, most vehicles have what's called active discharge now, which is going to discharge the capacitors in the inverter basically within half a second. But, this vehicle is, it's in the workshop, so it has a problem, so we need to check that out. And basically every vehicle has an inspection point. Sometimes that's under the inverter, sometimes it's on the battery case, behind the contactors. Really depends on each vehicle. So again, read the manufacturer's specifications. But essentially that's coming from the high voltage battery going into the inverter. So what we want to do now is we want to perform what's called the live test. So, and again, testing the students. The beauty of the Fluke is we get the students, do they put it on AC or do they put it on DC? Obviously they want to put it on DC. So put that up here for a second. I think you can see that, that's okay. And I just want to make sure that my meter is actually working. So you can see here I'm testing on the 12 volt battery down here, and we have 12.3 volts. Okay, the point of that is to make sure that my meter is working, which it is. Now, when I come back down into test the actual possible live high voltage, we want to do, which is also covered in all of the standards that I read, is use one hand rule. So understand and use the one hand rule. So to encourage that, I always get the students to put their hand behind the back. Otherwise, the deal is, if we make a mistake, it's just about, layers and layers of safety. But if you make a mistake, you don't make yourself a circuit with your heart in the middle. So, that's the basic concept here. Now you can either put a crocodile clamp on these connectors, or if you can do it with one hand, great. So come down and I measure here, and then we see on the multimeter that it's again at 0 volt. So, okay, live dead. So now we know that the voltage is dissipated from there. And we come back to our battery now, 12 volt battery, to perform the live test. And so now we're just testing to make sure that we didn't just blow up our meter, and made sure that everything there is okay. So 12 volts, everything's good. At this point, if you want to remove an inverter or air conditioning compressor or something like that, you can now remove the gloves. This is the verifier. The system is safe. It can't be restarted again. We know there's no voltage within the system. So great. But we're going to perform an insulation test here now. And so it actually states that because the insulation test can be 500 or 1,000 volts, we should still keep our gloves on. So what we can do here is perform that now on the breakout box. Now, if you go to a real vehicle, you would now start to isolate different parts of the vehicle. So remove the cables going to the motor, which is something I totally forgot to do here. Ignition's off, but reading the scan tool here, again, normally do that, sorry, but it tells me there that the motor generator has a P3009 code, high voltage leak to ground at the MG. So I'll show you what that looks like after. But essentially we want to test the motor generator for a high voltage leak. If you do that on a real vehicle, you have to start removing all of the cables coming in, because otherwise it's looking along the whole part of the circuit that's connected together. So to isolate phases or to isolate cables, you need to start removing them, testing them individually. Here it's about trying to understand the concept as opposed to the mechanical proficiency, and that's what you learn on the vehicle. But obviously, I was a TAFE teacher as well, so I know that vehicles often get damaged with students that are a little bit stronger than they probably expect they are, and breaking bolts and threading threads and things like that. So what I want to do first though is just show what the difference between an ohm test and a mega ohm test is. So mega ohm is also another name, mega ohm, or mega is another name for an insulation test. So you can see here I'm on the ohms measurement, and I'm on the ohm side of the multimeter here. And you can see, okay, open circuit, everything's good. It's out of range, there's no leak to ground. The problem with insulation testing is, you've got motors that have obviously insulation within them, the varnish on the windings and things like that, or you've got cables that have thick and very high resistance insulation on them. So the problem with that is an ohm meter is probably going to, so you can put the ends of the ohm meter into a voltmeter and it'll probably be around 2 to 4 volts, something like that, and that's not enough to break through that insulation. So, the vehicle didn't go into a red mode, it's come into a yellow fault situation, and so it's probably in, it's not a heavy short circuit, so to say, that's an absolute short circuit to chassis. That would be a different situation. So what we need to do is go to insulation testing, and you need to switch the leads around on these as well. And now we can change the range 500 to 1000 or however, but if I do an insulation test now, you can see the breakout voltage here, so 370 volts, that's the voltage the meter got to when it broke through the insulation there. So 0.3 mega ohm, 300,000 ohms is nowhere near enough for a vehicle like that. So that's obviously where we're going to find the fault. If I've just come over to another phase here on the motor generator 1 instead of 2, I'll get that in, it's a little bit out of focus. You can see here, that's a pretty good range. So that was over 500 volts. I'll even switch it to 1000 volts and you can see it gets over 1000 volts and still no problem. So that's the general idea behind an insulation fault like that. So in this case, the student would then say, okay, and they can test all the other areas here as well, that's fine. They can go here and say to the teacher, look, okay, I've got that now. Teacher can get rid of that fault, and student puts it back together, and away you go onto the next job. So I don't think I worry about putting that back together, time's getting on. But put the system back together using, obviously, safety lockout box, opening it back up, putting it back together. Loads of things to go through. And again, if you want to have a look, what I'll do, I might just make this, so I've got a poll here, I'll make that live so we can, if you're all there, just let us know if you're interested in knowing a lot more about this or anything like that. So that's live there now.
While you're moving across to the other one, and obviously we're mindful of time for everyone, so we won't necessarily go into the same level of detail, and that poll is helpful then that I've just seen. There's a question around, do you use why don't you use a Faraday box for the key, or do you not use one?
This actually is a Faraday box, believe it or not. Yep. So I've had a smart key inside here. I thought I'd get tricky and I used my phone, put the phone in there, and I called myself and it worked. But I put the key in there and had the key on my lap inside a vehicle and tried to start it and it didn't start. Okay. In the end, it's not so much about moving it 5 meters away, locking it in the office, putting it in a drawer. You should do that, absolutely, but always go back and try and start the vehicle. Foot on the brake and go into, try and get into ready mode.
Cool, thank you. I'll let you move on to the next.
And just to bring it back to time as well, if you've got to get going, absolutely understand. And we will record this as well. So if you want to catch up on anything later, we can do that as well. So, but on the downhill straight here, we won't spend too much time on the rest of this because I know, David, you want to talk about planning for laboratories and all that sort of thing as well. So let me get rid of that. So, high voltage battery trainer, what does that look like?
Stop the poll so it's blocking their image, not right now.
Just seeing that the pole is blocking the view. I think they can close that if you want to. Yeah, they can close it themselves. Sorry. Okay, so this is the high voltage battery trainer that I was talking about before. Essentially, not focusing on how motors work or anything like that. It's really about a deeper look at the high voltage battery. So you can see here, we've got a printout of an 18650 cell. So that's the common cell Tesla used to use back in the day. They've changed basically a couple of times in the meantime. And you might ask, why do we have a printed one? Is it all fake? There's one inside here as well. There's an 18650 cell inside. The reason we put it in the box obviously is safety and repeatability, but there's also a number of relays in here that we can switch faults in. So high resistance inside here, and open circuit, which is an interesting fault to say the least. Essentially, you know, you've got a lot, it looks pretty busy here. You've got lots of cables going on, or at least the circuit diagram. The reason for those is that's the cell monitoring. So the way battery management systems work, you've got battery balancing, internal battery balancing occurring inside the system. The way that works is to basically have a sensing wire in between each one. And the other thing that you see here is also these little blue things, they're the sensors, so temperature sensor. So when it comes to high voltage batteries, really important to have voltage sensing as often as possible. Not necessarily on every cell, because obviously with a Tesla Model S there's something like 7,000 cells in it, but certainly strategically placed to monitor as down to the lowest level as possible, and also with temperature. So the temperature is these guys here as well on the side, so that's what's going on with how busy that is. So we've got a huge amount of people looking that want to do a technical dive on this, so perhaps we'll look at doing that pretty soon in the next month or so. So won't go into huge amounts of detail, but let's at least have a look at the system as it is right now. So what we've got here, one of the big things we found is having access to the battery. So you can have a vehicle, doesn't matter what vehicle it is, but to gain access to the really deep levels within the battery, you really need to essentially have a manufacturer scan tool. And so, not all of our customers have that possibility. So we ended up developing our own scan tool so that you don't need any of those extra scan tools to do that. Essentially the system here, again, the entire e-learning is there. It's another huge system that has probably good 30 hours worth of training on there to go through. And so that's looking at these faults in particular. But one fault that I just want to show you, something really cool that I'd love to show normally is the high voltage relays, contactors, system main relays, what the startup kind of process is with pre-charge, main, negative relays. But I think we'll wait for that because it takes a little bit of time to set up. Essentially here with a scan tool, what I want to go through is just show that the cell voltages that you got here. Now the reason I've got a difference in state of charge here, I had the system running before and it got a bit flat, and that's why it's there. But normally on all our other systems you'd see the 4.1 on one side, 4.03 on the others. Normally that would obviously be all balanced. What's really cool with the system, as it gets up to the threshold for the battery management system for these types of cells, gets up to 4.15, and it will begin to balance individually. So it'll switch off, and that's what's really interesting. It uses these voltage sensing wires to measure the voltage, but also to to use it for battery balancing. It can bypass the current going through that particular cell in order to stop it being charged up further. But one of the main things I wanted to show here, with temperature, go through, measure the temperature. This is perhaps one thing I will just show, talking about battery management system, temperature management. So, classification of thermal problems. This is really interesting, and the way they do it here in Germany is they say if there's a vehicle that comes in with a potential temperature fault within the battery, which we'll show really cool next, you should park that vehicle outside and determine whether or not you can drive it inside or should drive it inside. So this is a basic example, but if you've got a high temperature somewhere in the battery, is that cell actually hot, or is there most likely a faulty cell? And so you can kind of see that there. And what the difference is if the cell has been damaged, what you'll see then is a radiation of that temperature coming out from a point. And so you need to determine that. You should determine that before you drive into the workshop, not after, because obviously if the vehicle burns down, you lose the whole workshop, all the other cars. And that's built into the training here in Germany, for example. So, and measuring that, we can switch out faults for the temperature sensors. You can put high resistant sensors in there, so the students would see one cell that's at 80 volt, 80. Again, got the German word in my head, Grad, 80 degrees. Sorry. Okay, so again, I could go on for the next 5 hours about this, but conscious of your time, so I won't. One last thing that I want to show here though is let's just put in a fault, short range. So out there, I'm not sure if you heard it, but in this one here we've got relays that we can activate inside. So just by switching on that page, I've now activated a fault within here. And this is a good way to highlight to people about high voltage batteries. You've got a high voltage battery. We all heard about vehicles getting shorter range, and what that is normally a high resistance in a number of cells. Now, high resistance within a battery cell is something a little bit difficult because it's not necessarily about, like, you can't just go along and measure resistance of a battery cell. It's a power source, you can't do that. And so you can often see it in a scan tool, but it's calculated. And the way they calculate it obviously is voltage and current. You can work out the resistance. So, but what I see over and over again is people will remove a battery and then they think, okay, I'll measure the voltages and then I can just remove those cells. But the problem is the initial voltage is still going to be at that same level, or it can still be. Obviously there can be cells with dead voltage as well, but one of the potential problems is that all of the cells will look exactly the same. And so, if you take that battery out and then start doing the measurement, it's a little bit hard to work that out because, as I said before, I've got a difference of the two modules here. That's not normally the case, but there's nothing that's sticking out here as to something that's way out of range. The reason, well, normally what you would have to do is test drive that vehicle and measure all of these, go through the data, and then try and find any of the faults here. And now all of a sudden, when I put the system under load, now I'm getting a high voltage fault because there's more than, say, 0.1 or 0.2 volts difference between the cells. And you can see on BMS 1 on the right hand side here, slot number 5 is clearly at a lower voltage than all of the others. And you can see that with regeneration, when it's regenerating, it's actually much higher as well than all of the others. So yeah, just a little piece of interesting information there as well. So again, looks like lots of people have asked for a workshop on that. So might just go over to the last unit that we've got here. and that's the first responder car train. So just have a really quick look at this one as well. So just to give first responders an idea of how these systems work. So it doesn't go into the detail of how the systems work. It's more about giving them the ideas and go through certain scenarios to understand what the systems are about. You've got all of the different types of cut loops and things like that. Just move this out of the way. Cut loops, so you often find firefighters, they don't care about the service plug. They just basically have a loop that you can cut out, and then that should shut down the system. You also got emergency fuses here as well. So pulling those out, and you can see the voltage begin to dissipate for this instance. So it's really a way for them to understand, and this is, you know, the international standard for rescue cards. So the colors, all of the different things that you see here, understanding where the cables, where the high voltage components are. It's exactly as you would see that. So just a really interesting way for them to understand that. And it's done like this visually to see under which conditions, where is voltage. So a good example is always at the high voltage battery here. You know, I can remove the cut loop. Now you can cut that, we have spare ones there as well, but just to do it quickly, you can see that, okay, there's no voltage here. If I need to access the front or the rear of the vehicle, that's fine. But if I, somewhere around the high voltage battery, need to understand that that's always at high voltage there. And so for example, again, I'll do it without gloves, but the high voltage battery is only isolated to a certain degree once you have the service plug removed. So just some of the things. One last thing that I'll show you is we have also different scenarios. So you click a button here and essentially the smart key, the system will remain on the whole time. So like the contactors have been welded. Heavy damage at the rear of the vehicle, what can happen, vehicle underwater, burning vehicle, trapped driver. So click on any of those and it'll just give you an idea, or give the firefighters a scenario to go through that they might encounter, just so that they can help develop their ideas, see what's going on, things like that. So as an example here, I've got like a thermal camera. It's a little bit hard to see, but I think once we get across there, it might be a little bit easier to see. So, and this is actually not necessarily just for firefighters, but also for some technicians, but it's definitely, sorry, move it slowly so we can see it. So there you go. Here we can see an actual hotspot within the battery here, which is a good indication that there is a potential for thermal runaway. So just as a situation that firefighters might come across, to be aware of and to act accordingly. So I think, David, that's probably enough, more than enough for our practical session for today.
Yeah.
Again, there's plenty of things that we can go through for hours and hours, but I think we'll leave it at that for today.
No, you've done really well. Thank you. I think everyone will have enjoyed it, found it interesting, and I think the poll's a great idea in terms of being able to offer some additional time and training, and it's one of the things I've talked about here with a number of our customers is, as part of that lab planning process, how they upskill themselves as well as, and to be confident in front of the class, to understand the technology. And working through the courses is one thing, spending time with you is another, and working with our team too. So no, I really appreciate it, and I think, as I said, the polls are showing some good numbers, so we'll have to organise that with you soon. So Thank you.
Absolutely, no worries.
I'll let you have a look at
interesting for everyone.
Yeah, I'll let you have a look at a couple of the open questions. I'll just share the screen here as well and talk through a little bit about the lab planning process. Obviously, we talked a little bit about the equipment here. I'll put them on the screen. As you said, we'll make the recording available for different car trains. And we're looking at a couple of the learning outcomes, but as you mentioned, there is hours and hours of relevant practical tasks that people really need to integrate into their training. And if it's not in training packages now or in qualifications towards regulations, we know that it's coming. So it's certainly an interesting space. And really, that's what it comes down to with the lab planning exercises. Opportunities like this to meet with you and your counterparts in different areas, different subject matters and fields. But effectively, it's always looking at the learning outcomes and the objectives, both now and then what's the short, medium and long-term hold in those areas. And really then the focus is on integrating and developing solutions with equipment that is industry relevant so that the skills that are learned in the training environment are directly transferable to the workplace. And to couple that with then the academic journey of the students and trying to get some consistency there, but also importantly, the academic and the administrative activities of teachers, being able to deploy solutions that have that consistency through the journey, as well as providing the administrative benefits for enrolment, assessing student progress, maintaining evidence of skills developed, and of course, competency is of real importance. And I'm sure you see that around the world, but we know it's just critical through Australia and New Zealand. And that's why I think over the last kind of 10 years, we've seen a real increase in the number of institutes driving content through learning management systems. Things like Canvas, Moodle, Blackboard are pretty much now all familiar terms. How content is driven through that differs institute to institute, but obviously they offer a lot of benefit. And the e-learning content that you showed along the way there, we've got clients now that have that natively in their learning systems, that they're tracking student responses. They can really mentor students in ways and understand where strengths and weaknesses are, either individually or in a group of students. So I think that's a really important element of it. Obviously, to then couple that and develop that plan as part of the implementation phase before equipment gets commissioned is so beneficial to the rollout. So we keep encouraging that along the way. One of the things that I think you and I have talked about in the past is that not everyone knows really where they want to start or how to start. Some clients have engaged us because they know they want to improve their educational offering with modern training resources. They recognise that taking the old bit of equipment into a brand new building isn't a good solution. It doesn't engage the trainees, doesn't benefit the employers, but they don't really know where to go next. And so I think that's why we offer those free lab planning sessions, and to be able to develop concepts, take them into actual lab environments, to go to work with, as I said, yourselves, and to really develop some leading training labs. And I know that whilst those images all talk about labs in a big grand sense, not all the solutions are done in that manner. Obviously, we have some that have big scales like I've shown you there, but often, given that the solutions are scalable, and you can see just behind you, just a couple of panels and how meaningful they can be. I'm sure we've also seen over the years, I know we've seen it in Australia and New Zealand, I'm sure you've seen it in other places, where clients will start with the fundamentals of the technology, some core key technology systems, move into specialist areas, or vice versa. We've had clients start very much focused on some advanced areas of electric vehicles, and then as the opportunities presented, they've added to the range of resources with more of the core technology, be it ignition systems or networking systems and the like. So I think that's again one of those things that gets uncovered as part of discussing priorities, understanding budgets. That's a big part of the process. But yeah, I think that's really a critical element to the planning stage.
And if I can just add something there,
Yeah,
David, sorry. So you're talking about, what's that step into kind of moving into training for this as well? So it's sometimes, how do I start, things like that. And so we try to make this as plug and play as possible, and together with what you guys can offer there as well, with the extra training and support, obviously from our side over here, I love to work with anyone back home, obviously, and it'd be great to see this at World Skills Australia one day as well. Would be good. But that's we got dozens of these in the US as well. So it started out well in California, and now it's kind of moving over to the east as well. Tesla, for example, using these. Just like to mention that wasn't really relevant for this. We've got McLaren. We've got special McLaren units with a McLaren vehicle and a Tesla vehicle printed onto these. But
the heavy vehicle one as well. That
heavy vehicle, where is it? That side there as well. It came about from a teacher who in California, who was heavy vehicle program, does all of the training for Freightliner, Volvo, Daimler, things like that, heavy vehicle. And he was saying, he was at that point, he had to develop a program. I went there and spoke with him and showed him, and he's like, okay, I can use that as a plug and play that covers everything. He had his standard there, what was covered, what had to be covered, all of that. And we also go through electrical fundamentals and stuff like that. And it's just like, okay, yep, that. And he said, what's a shame though, it's got a car on it. The technology is exactly the same, but can you guys just put like a truck on there? So, we do all the printing here. Everything gets made, in the building that I'm in right now.
Yep.
And so we got a 3D animation of a truck, printed that on there, and, we've changed it to 24 volts. Essentially, the technology on the board is essentially the same. It's still a high voltage vehicle. The concepts are similar, if not the same. And then what we're doing now is changing the e-learning to be more focused around heavy vehicle. But the teachers that purchase this unit, they're kind of on the edge of, you've almost got to put the fear of God into these students when you're, with a group of 16 young guys, and you're about to watch them do the verify, touch it. Now they're on the real high voltage of a vehicle. Mm-hmm. You want to be there with them. What's everyone else doing around the class? And so, the teachers, we're telling them, you've got to be careful here now. And some of the students just start freaking out, as they're about to measure it, they're shaking and all that sort of thing. And so they say, look, go on one of these units, just go 10 times, go through, understand you're using the right gloves, you're testing them, you're using the right meter, things like that. Just go through it, develop that muscle memory and that culture of safety.
Yeah, and that's the nice part with it, is that you've got something that's measurable, repeatable. It doesn't cost any extra, but it helps students build confidence in that approach, and that's really important when you're talking with the safety elements here. And that's something that we've been talking about quite a bit with customers of late, and really throughout the journey. Over 20 odd years, we've seen really good bits of simulated and emulated technology that comes in to complement the whole, as you said, blended learning approach. This is right in that space, and it gives students an appreciation for things, allows them to practice, and it's fantastic. So we've been talking now, and the hard thing always is trying to get that measure right. Funding is often uncertain, especially in these times. I think everyone would love to have labs full of all the gear. It's when that funding does appear at short notice, and you have that proverbial proposal in the top drawer so that you're first in line. Everyone sees the benefits of the gear. I haven't had anyone really come back and have any negative feedback around that type of approach as part of their learning. So really well done to you and the team in the development stage of it there.
Thanks. It's something we believe in as well. It's I put my name behind it. I think that's real benefits to what it can do for automotive training. Yeah,
I don't see why there isn't a core group of providers to really build those EV centres of excellence to help propel the technology to, support the uptake of the vehicles. We've always been, you and I and our organisations, that we remain open to having the discussions with the training providers, with the industry groups, to when they've got an interest in electric vehicles and a view to offering those kind of certifications and standardised training. Both Training Systems Australia and Lucas Null are right behind it, so we're always happy to offer our time. We just want to make sure that vehicles, which we know are coming in greater volumes, are, the infrastructure is there, the resources, the human resources that need to be skilled are ready to do it and ready to do it safely. So,
absolutely. Just want to say thanks to everyone that sent through links to that new ARU package there as well. So that's good. I wasn't aware of that. So I've been out of the loop in Australia for a little while now. So it's good to keep up with things like that. And so much appreciated.
Yeah, and there's also a note here that from Matthew saying that PwC are about to release some specific heavy vehicle EV modules too, which will be of interest. So we'll have to keep across those too.
Yep.
Just looking at the other questions, and we're happy to stay on if there's more questions coming, but I mean, we thank everyone really for their time. Daniel and I are both happy to keep chatting. There's some questions here from John. What's the recommended PPE for safety boots for working on high voltage vehicles? The standard steel toed boots a risk?
Yeah, basically, so what I'll do is I'll just go back over here and share my screen. So safety footwear. So yeah, normally we know steel caps, but they definitely recommend to have non-steel caps. So sometimes you can use these overshoes that they've got here, so you can kind of wear so non-safety boots and then put those over the top. So, and they come in different types of materials, but essentially provide the same protection but without the steel in the boots there. And while I've got this is my favorite, the technician disconnect tool. So when someone gets electrocuted, you can pull them away. So yeah.
Super helpful. People have been asking about how they can access the recording, so we'll get a link out in due course pretty soon to people. So
yep,
that's fine. We can do that.
And we got good results from the poll there as well. So we'll have a look at doing something. Especially, we have some recorded that we've done for, say, like California Automotive Teachers Conference. We've done those. They're an hour and a half. But we're happy to do something, especially for you guys, that could possibly be a little bit more interactive. And I'll get a couple of the other product managers here as well, and we can do that. So that's also, it's always good fun. You guys have a beer and pizza while you're there, and we'll.
Sounds
good. Early.
Sounds good. A bit early on your side.
Yeah.
It's getting a bit late. Once we catch up with the daylight savings times in New Zealand, we'll be there shortly. So, but no, I appreciate the offer. Thank you. Did you want to have a look at any of the other questions there? Lots of appreciate all the positive feedback from people. Thank you to everyone that's
yeah, absolutely. Yeah,
there. It's very much appreciated.
Thanks.
Glad people found it interesting. So, Dev, yes, we've got the detailed training demos, so we can cover those off at any time. I mean, we encourage people to really get in contact, and we're happy to spend time looking through individual panels, and that was my point with the lab planning. Is it doesn't have to be a full lab plan. It's just understanding the particular area of training you want to cover, and then we can run through demonstrations and talk at length about those, look through the courses in detail, look through the panels, talk through it, and run some demonstrations. So very happy to do that. We'll put our details with the link when we send that out, so everyone's got it too.
Yeah. Okay. There's a few questions, but thanks. Yeah. Yeah. No. Well, also from my side, thanks very much for everyone. Yeah. Hopefully get back to Australia one of these days. had a couple of trips cancelled.
Yeah,
But
understandable.
yeah, we'll see. Hopefully next year. But be good to be able to do some perhaps live training back over there one day as well. Be good to have anyone interested catch up.
You touched on before, there's a question that talks about, you know, in automotive workshops, how this training is done and how these panels compare. I mean, you touched on Tesla and McLaren, and obviously some of the OEMs that are using it. I know we've talked about the fact that the overlay mask there can change into different drivetrains, and you've got fuel cells, you've got full electric. You know, in terms of the reality, I guess they must find it a direct correlation between the two.
Yeah, again, it's more about the system understanding. So obviously, you know, when you're doing an insulation test on a vehicle, it's going to be a bit different. You've got to start pulling covers apart and gaining access to the cables, things like that. So it's more about understanding the system as a whole, because, you know, as I mentioned at the start of that presentation, there's so much new technology here. I think, you know, we're kind of in a learning phase as well. We've got to understand what three-phase motors are, all that sort of thing. So, you know, old school, understanding ignition patterns, injector patterns, all that sort of stuff. And now it's just trying to learn all of that. And so as far as hybrids, you know, as I mentioned here, we've just got 5 main types. If you look at in detail about what all the different types are, it can, like, literally, you know, they've got a clutch in between here, or they're connected here, or this, that,
Sure.
you know, it's all goes into great detail. So it's not so much about that, it's really understanding. And McLaren, for example, you know, they got this, they only have a particular type of hybrid, basically a parallel hybrid that's, you know, the electric motors using it as the electric motor is used as a booster for the combustion engine, essentially. They don't have electric cars, but they wanted this. They still wanted their people to understand different types that are out there. But essentially for them, it was the isolation procedure was also really important for them. So it was mainly about that and performing some of the insulation testing and just developing diagnostic pathways as well.
Yeah, the skills, understanding the process and the approach. So
Yep.
Makes sense.
Exactly. So understanding what the, you know, all of these testing devices are, and something, not sure, I didn't see it in the skill sets or anything, but something called potential equalization, which is like a little cable which goes from each of the components, the compressor or the inverter, to ground. So essentially, if there is any high voltage leakage onto those components, you know, maybe people have seen that there's a pretty famous, I think it's Formula One with a KERS system. A vehicle pulls into the pits, and the chief mechanic puts his hands on 2 different components and gets a shock. It's because there was no potential equalization. And just on that, we had BMW or Andretti Racing. So Andretti Racing is together with BMW Formula E.
Yeah.
Guys, so long story, Andretti Racing is in the US, obviously, but they are quite big in the UK as well. So, and a lot of these formula level mechanics from the UK, the Andretti vehicle is a BMW, and so the guys from the UK had to come to Germany to work on the vehicle at the BMW factories, and they weren't allowed on the factory until they had that DGUV training. So they actually came here. We don't normally do the training, but just through our contacts, they said, look, we need it. We need to get our guys trained before we're even allowed to get into the factory. So we did that training for them. So
well done. Yeah, and that's the thing, is that there's going to be these areas of the automotive sector that haven't necessarily had their electrical training done for a while, and there's a lot of upskilling and electrical refresher courses, I guess, that's going to be part of it as well. It's really about taking everyone on that journey to get them to the spot we want, because I imagine that regulation will follow suit here, and that, you know, whether it's the work cover authorities are going to really insist on there being, you know, business insurers as well. There's got to be with this a whole package. So I see a lot at play there for the industry groups and the
Absolutely.
representatives. Yeah.
Yeah, I'm pretty keen to check that out now and see what's inside there.
That sounds good.
One of the other things that we're seeing as well is that on the heavy vehicle, you know, a lot of the fleets, council fleets are switching to electric vehicle, garbage trucks, public transport, all that sort of thing. So, you know, we've got, there's a California company, Proterra buses. I think the Olympics are in Los Angeles, like in 2028 or 2030 or something like that. And they've said all public transport is going to be electric. And so this company is like in the same position. How the hell are we going to train everyone? And so we've put a prototype into them for a bus. So we've got the bus on there as well for them to do it. So that's probably the next thing is the fleets that are going to start doing coming in. You know, it's going to be the driver for this, and it's probably not a bad thing to kind of stage the training as well. Like and that's kind of what's going on in the UK. They're just like, oh my God, we've got to train everyone all of a sudden. Yeah. Australia's probably got a good chance to stage that now, you know, with fleets and things like that. So, you know, the uptake in Australia is not going to be as quick as, say, here in Europe, but it's definitely going to come.
Yeah, I mean, we're hearing conversations. There's work obviously happening around, you know, fuel cell buses. There's a lot happening, and given the nature of the country and its size, you can imagine those fleets of electric vehicles and efficiencies are just going to continue to grow and be of more and more focus.
Yeah. Interesting fact about the UK, talking about infrastructure and the size of the country. So someone told me the other day in the UK, they have, to reach their goals, they have to install 700 chargers per day.
Unbelievable.
They're not even close to that. So, yeah.
Yeah, it's a huge number.
Yeah.
But, yeah, we'll, I'm sure they'll give it a crack, as many as they can, but it sounds like a goal that can't be necessarily achieved, but who knows? They've committed to this cause, but...
As long as the government puts the resources behind it at some point, you know, can make all sorts of things happen.
Yeah, that's right. I mean, a lot of it's going to come down to incentivising people and organisations to really get on board. So, just seeing if there's any other questions. I think we've covered most off in our chats here. Just a few more thank yous.
Sounds like the NBN rollout. I'm not sure if that's a good thing or not.
It's held up for this session, so there you go. No.
True.
All right. It does sound like the NBN rollout. So we won't get on to Brexit or anything else. Not politically inclined here, so we'll stay clear of that.
Exactly.
But no, I think, there's the last couple of comments here that was just saying, I mean, obviously, there's a lot in the electrical training packages that I'm sure are being borrowed for what's going to happen here. It's upskilling a new set of workers that haven't had that kind of level of exposure before. So it makes a lot of sense.
Yeah, and I think, so, you know, we're hearing a couple different things, electrical and all that sort of stuff. So, yeah, I think that's part of the discussion that needs to happen is what is going on, you know, and that's kind of probably certainly above my head. But I know there's some people in the webinar today that we're watching that are certainly in a position to, you know, lead discussions like that. So it's possibly a good thing to happen in Australia. I'm going to make it clear to everyone what's the stand right now, what's the immediate future, and what's the long-term goals. I think regulation, licensing, things like that would be great. Mark Raybone, good mate. Worked together at Murray Bridge there. Great to have you as well. Thanks, mate. And yeah, looking forward to catching up next time as well. Yeah. Also, Ron's been here to visit us here in Cologne. So looking forward to seeing you again at some point, Ron.
We look forward to be able to get over there again.
Yeah, that would be good.
little bit of time to go.
Special beer here called Kolsch. So
It's good. Yes.
come and try it.
Yeah, it's very good. Les and Thomas, your colleagues, have taken us out and hosted us with us, and it's a good evening, that's for sure. So Daniel's asked also again here, will this recording be available? Absolutely. We'll send out links to everyone that's attended, registered for the night. So we'll get something out to you soon. So
right. Oh, we're at pretty much 2 hours now. So
yeah, no, I appreciate your time. I think we've knocked all the questions on the head. If there's any last questions from people online, please feel free to send them through. But we do appreciate so much of your time. And unless we see anything in the next minute or so, then we'll wrap it up and call the webinar closed. But
yeah, well, thank you, David, as well. Thank you for everyone. New Zealand's probably getting pretty late over there as well. So thanks very much for hanging around.
They've had daylight saving kick in already, so extra hour off usual. So
yeah, excellent.
More than 3 hours. It's a beautiful country, so it's nice. Look forward to being able to get over there again soon too.
Yeah, absolutely.
So, yeah,
absolutely. All right, mate. Well, thanks again. Thanks everyone for joining.
Thanks to everyone.
Take care. All the best. Cheers.
See you. Bye.